Dear students, in this class we will be taking up chapter 1 of class 11 physics, motion along a straight line, also called as one-dimensional motion. So then let us just give an overview, summary of what kind of problems will come across either in NEET or JEE Main or JEE Advanced. Of course, now in this module we will be talking at the NEET level, that is the fundamental level, basic things which everybody should know. And then during this we'll also be adding up as and when required certain additional material which will be mainly covering the JEE main level as well as JEE advanced level a little bit. But of course, the main accent right now in this particular class is only for the NEET level, funda level, which should be understood by everybody. Now, as I said, let's first have a look at a kind of a summary overview of what kind of question, what kind of topics will be covered in this chapter, and then what kind of problems will be expected in the NEET exams. Then so now we will now see there are now in this motion along a straight line there are three types of motion on which questions will come. Now the first type of motion is constant velocity, and therefore now in this type 1 you will come across problems to do with average velocity, finding out average velocity. There are actually now two cases will be dealt with average velocity, and as you know, average velocity is total displacement by total time. Now if a particle is doing one-dimensional motion along a straight line from, let us say, point A to point B, then if it covers half the time of the journey, it travels with a velocity v1, another half by v2, then what is average velocity? That kind of a question will be covered under equal time intervals. Now similarly, now the same kind of problem can be treated as, now the total journey can be subdivided into two equal parts of distances. Therefore, half the distance covered by v1 velocity, other half by v2. It could be actually half and half, or could be 1/3 of the total distance covered by v1, then the second middle 1/3 by v2, etc. Now such kind of problem come under this case 2, which is equal distance parts. Therefore, either case you will be asked to find what is the average velocity for the entire journey. Such kind of problem is what is generally come in this constant velocity. We will also have relative velocity problems in the constant velocity motion. Like for example, now your bus may be there and then traveling with a velocity, and a car will be following with a certain gap of distance, then overtaking kind of problems. Therefore, what time and then after covering what distance the overtaking takes place. So that kind of problem is coming across in this relative velocity problem. And under the constant velocity case, we'll also be talking about constant acceleration later. Right now we are talking about the topic which is the constant velocity, or it's also called, as you know, as uniform motion. Then could also be now like this. Now swimming. Now suppose now a river is flowing in the direction and the river velocity, and the swimmer is now flowing downstream and upstream, covering the same distance. Then what happens is his speed will be more when he is traveling downstream, and then less when he is traveling upstream. Therefore, then what are average velocity? Such kind of cases will be coming across in this swimming in a river downstream upstream cases. As I said, we are just now quickly going through a kind of summary of what kind of problems are expected. We'll be dealing with this kind of problem. We'll be solving them. We'll be taking some sort of examples and solving them as we go along. Now the next thing could be now escalator. There is a typical problem that if the escalator is supposed to now take you without you climbing the steps. So then, if it is a stationary escalator, you take some particular time to climb the steps. But if you are now using the escalator, and the escalator is now taking you up, then it will take time t2. Then what happens if you happen to walk on the steps of the escalator and then reach? What is the time which is required for the same escalator? Such kind of question come under escalator type of problem. A typical problem you would have come across already. We will be solving them. Then as I said about the bus car overtaking situations. Therefore, now we have now covered the constant velocity topic. What kind of problems are expected? Now this is a typical problem. This will not be the complete exhaustive type of problem what you come across. You may come across certain other types of problems also. Of course, now we will be now helping you to. I will now be teaching you enough so that you can solve any kind of problem coming in this particular topic. Next, of course, we will be taking the constant acceleration. Typical this thing. A large number of questions will be pertaining to constant acceleration situations. And of course, now the first kind of topic is using the equations of motion. As you know, there are mainly three equations of motion: v equal to u plus at, s equal to ut plus half at squared, v squared equal to u squared plus 2as. Now also you know about that travel in the nth second formula. And then of course now there is one more formula which is there, which I will be teaching you, which will be very helpful, because this is based on average velocity situation. What is average velocity? S by t. Therefore now you take the t here. Therefore what is s by t is nothing but average between u plus v by 2. Therefore, this is what is the formula based on which you can solve quite a number of problems quickly and then efficiently also. That we will be covering in this The next topic which will be coming under the constant acceleration problem is now there can be various stages. Like for example, suppose now a particle is traveling from some point A to point B with some acceleration, and then at point B it changes the acceleration to something else, and then travels to point C, and then the retardation or maybe uniform motion. The combination of various types of acceleration coming in, then you'll have to treat them as a kind of multi-stage problem. That is, you treat, if it is one value of acceleration, you are treating it as one stage. Therefore, like for example, now A to B, the constant acceleration, let us call it alpha. Then what happens is, now you start with A, initial velocity, and therefore then finding out what the final velocity at B. Then use the final velocity at B as initial for the next stage BC. So like that, you are splitting the whole problem into multi-stage, into several stages, depending upon how many different accelerations are coming. Such kind of a splitting is very important so that you can solve the composite problem. Now such kind of example will be taken up in this single stage as well as multi-stage kind of problems. Then of course now we have graphical situation. Now typical questions will be based on the graphs. Now as you know if you have a velocity versus time graph, velocity along y-axis, time along x-axis, then the slope will give you dv by dt represents acceleration, as well as now area under the graph v versus t will give you the displacement. So the such kind of approaches, and then you may be given a certain type of graph, velocity versus time it could be, or even it could be displacement versus time, or even it could be acceleration versus time, and for such kind of a thing, if for example acceleration versus time graph is given, then you know now the area under the acceleration time graph gives you the change in velocity. So then depending upon that, you will be given certain number of questions. So then that is how it is like this. Then that is as what I now narrated here. Now the slopes of the graph v equal dx by dt, a equal dv by dt, and also now there one more formula which will be very frequently you will come across is acceleration can be defined as v dv by dx also. So based on which certain amount of graphical question based on slopes. Then as I said about the area gives you, the area under the graph gives you this kind of thing. That is v versus t graph. This will give you displacement area. A versus t graph, as I told you, is going to give you the change in velocity, delta v. As well, a versus x graph is also, as I said about, because a is equal to v dv by dx. Therefore, a versus x graph. Now, a dx will give you, as you know, integral a dx. The area under the graph will give you v squared by 2. Okay, like that. Okay, based on the integration. And for such kind of problems, we'll be dealing with now during the course of the class. And then we have the whole class of motion. Whatever now we are talked about is uniform acceleration could be on a plane, whereas now if it is on the vertical plane, free fall under gravity, where acceleration to gravity is a constant g equal to 10 meters per second squared downward. Now that is called a motion under gravity. There will be a lot of kind of questions as well as problems which will be given based on the motion under gravity. That nothing but slight modification in the equation of whatever we already know about the equations under constant acceleration. Just apply a equal to g and downward g, and then using it you can actually modify the equation, and then also you can arrive at certain well-known formulas which we'll be dealing with as the class goes. Then most important aspect in this free fall under gravity is the sign convention, because when the problem, for example, is now your stone is thrown upwards, vertically upwards, with the initial velocity u, then u is taken positive mean. Usually what we do is, as a kind of a sign convention, we'll have to follow upward is positive mean, then your g, which is typically downward, g you'll have to put as minus 10. That acceleration is equal to minus 10. Therefore, now sign convention, you should be very careful in using sign convention so that you solve the problem without making any mistakes. That is sign convention importance. Then of course now reversing the motion is a typical technique by which you can simplify looking at the problem. So then that also will be teaching you now as a course, as a class goes on. Then of course there are some well-known results which will be quite useful in solving the problem quickly. Okay, now what are the well-known results we'll be teaching you. Like for example, one of the things which you already know is, if it is a case of a motion with a constant acceleration, and starting from a rest, let us say u equal to 0, then the distances covered in the first second is to the second is to the third second, or even the distance covered in the first let us say t seconds is to the second t seconds distance covered is to the third t seconds, etc., which will follow arithmetic progression, something like 1 is to 3 is to 5 is to 7 is to, etc. Now this kind of well-known result. Then there are some other kind of well-known result, which is if the free fall starting from u equal to 0 from a height, if a stone is dropped from a height with the initial velocity equal to 0, then the distances, then the time it takes to cover equal distances will be in the ratio root 1 is to root 2 minus root 1 is to root 3 minus root 2 and so on and so forth. That is T1 is to T2 is to T3. Now, such kind of well-known result will actually help you in solving a problem very quickly without having to do elaborate steps. So that also we will be teaching you now during the course. Then, of course, then we have a very famous relative velocity, relative acceleration approaches. Now this will be especially useful if it is free fall under gravity situation, because now suppose now you are dealing with now two particles, and therefore now usually it will be helpful if you are dealing with the motion of two particles simultaneously, then the relative velocity, relative acceleration approach is going to solve the problem quite easily, quite fast. Now, such cases, as I said, if it is a free fall under gravity, then the acceleration will cancel out, because relative acceleration is going to be 0, because both the particles will have the same acceleration, g equal downwards equal to minus 10. Therefore, now it will cancel each other. Therefore, it will be very ideal to solve such problems of relative of two particles free fall under gravity by means of relative acceleration, relative velocity problem. Then what happens, as I said, now acceleration will get cancelled out. Therefore, relative velocity, therefore, down to nothing but it will just reduce to a uniform velocity situation only. Therefore, it will be ideal way to solve such kind of problem that we will be teaching you. Then you have the type 3 problem, which is, so far we talked about type 1 is constant velocity, type 2 is constant acceleration. Now we will have type 3 varying acceleration. Here you will be using the calculus methods, either taking derivatives or by integrating. Therefore, now it's like this. Therefore, v equal to ds by dt will give you your, that is, your velocity is given by derivative of displacement with time. And similarly, acceleration is dv by dt. Acceleration also is by means of v dv by ds. Then, as I say, integration will now take you for v equal to integral of a dt is actually in delta v. Change in velocity is given by area under a versus t graph, that is integral a dt. Similarly, v squared by 2 will give you a ds integral, as well as s will give you v dt. Then we'll have one more this thing, in case now it is varying acceleration, then the average acceleration calculation is nothing but the total change in velocity divided by total time. Okay. Now, we are now given an overall picture about what kind of topics we'll be covering in this particular class. We will now get down into the detailed topic one by one, as well as now the typical problem which you will come across mostly in NEET, and then, as I said, we'll also be giving you extra module to take care of JEE kind of problems.